Okay, so this is a demo of the grid tie with limiter. So this is the limiter. This is a Sun G 1000G produced by Mass Power. The limiter was designed by Hertz Blaster in cooperation with Mass Power. So basically the idea of this GTIL is to limit the export of excess power to the distribution unit, or in my case, no export to Meralco. So since the sun is up, it's about close to 10 a.m. Let me show you what the utility power is showing. So it's only showing 3.5 watts because the GTIL is producing 155 watts. I only have 400 watts of panels. So let me show you what happens when I turn off the grid tie. So right now, the house is only consuming 150 watts. So the inverter is producing nothing. So let me show you. It's off. So let me show you once I turn on this grid tie. So it's booting up. Let's see what happens. So there you go, 150 watts. And let's see what happens with the utility power. Only 5.3 watts. It's slowly matching it. So the inverter is producing 146 watts. So again, I have 400 watts of panel. So I'm sure it's producing more than 150 watts right now. So let me show you what the utility meter is reading. There you go. It's only producing 0.14. So wait. So there you go, it's 0.
This is the switch gear for an 8.46 kilowatt battery backup and grid tied solar system. We have a 2700 amp hour battery backup present here, consisting of 12 225 amp hour batteries. These two yellow units here are the Sunny Islands 5048. Each one is capable of producing 5,000 watts from the batteries. These are battery inverters and chargers at the same time. This inverter over here is a Sunny Boy 8000. It is utilizing the input from the solar array above us and pushes power to the inverters, which in turn power the house, and all the excess is sold to the grid. Now, we separated a number of circuits in the house that are backed up in this critical load panel. This critical load panel is what's isolated during a power outage. Right now we're running a power outage scenario. At this very moment the main switch to the house is off. We've backed up a kitchen. Other than the lights, we have all the outlets in the kitchen, the computer station, the fridge, coffee pot. We have a freezer on the first floor. We have master bedroom and bathroom, and the pump for a solar hot water system. Therefore, if the power is out, we can still have plenty of hot water from the sun. The 8.46 kilowatt system, currently in a partly cloudy weather, produces 3 kilowatts of usable AC power. Of that usable AC power, 1.6 kilowatts is going to charge the batteries, and the rest is used up immediately. So in this situation, we're providing power for all the loads in the house and are charging the batteries for the nighttime. The system is equipped with online monitoring, available from any computer with internet access, as well as on the local network. As part of backed up circuits, internet access and local network will always remain on. When the power goes out, the switch is uninterrupted, therefore equipment never shuts off. If the computer is on the backed up circuit, it never has to turn on and off. The inverters at this time had turned off the grid tie inverter because the batteries are full, and they throttled the grid tie Sunny Boy down for several minutes at a time, just to actually be able to discharge some of the batteries. We've been running this test for the last 2 hours, and needless to say, we haven't discharged any of the batteries and still are making plenty of power. Again, this is an 8.46 kilowatt solar photovoltaic system with battery backup. My name is Alex, I'm with Power for Action Management.